All right, so last video we looked at quadratic functions in vertex form. This time we're going to look at quadratic functions in standard form. Now remember, I briefly mentioned what standard form was last time. It's y is equal to ax squared plus bx plus c. A determines the shape and the direction of the graph, same as last time. B influences the position of the graph, same as last time. C is our new one. This determines the y-intercept of the graph when x is equal to 0. Now, when we were in vertex form, we could easily see what the vertex is. For standard form, we need to memorize this. This is something that will stick with you forever as we go through pre-cal. It is very easy to memorize. The other way that we can do q, if we don't want to memorize q, is we can substitute the p-value, which is also x, into the x of the standard form, and that will get us the same value. So we're going to test this and work alongside some graphic. So if this is the function of x is equal to x squared, we need to find the coordinates of the vertex. So p is equal to negative b over 2a. We have no b in this case. And we have 1 for our a value, which leaves us with 0. So then if we plug this into q, c minus a p squared, we get 0 minus 1 multiplied by 0 squared, which gives you 0. You do it the same way that you plug it into f at 0 is equal to 0 squared is equal to 0. Either way works. It gets us the vertex point, which is what we want. So vertex is 0, 0. And we're doing this even though we know what this graph looks like in order for us to confirm what we're doing. Our max and min value, we have a min at y is equal to 0. Our equation of the axis of symmetry, x is equal to 0, x and y intercepts, y is equal to 0, x is equal to 0, domain, x is an element of the real numbers, and range, y is greater than or equal to 0 such that y is an element of the real numbers. So then we get this nice looking graph. And like I said, we know what this one looks like, so there wasn't too much legwork that we had to put in for it. But it was just really to confirm with what we were doing with the vertex. Okay, flip the page. Our next one that we are going to do here is x, the function of x is equal to x squared minus 2x. So if we look at this, the first thing that we're going to do is we're going to find the vertex. So p is equal to negative b over 2a. P is equal to negative 2 over 2 multiplied by 1. If we remember correctly, this negative, it doesn't matter where it goes, it just needs to be in there. So equals to 2 over 2 is equal to 1. If we plug this into q, is equal to c minus a p squared. C is 0, a is 1, p is also 1, squared is equal to 0 minus 1 is equal to negative 1. So we have vertex at 1, comma, negative 1. Let's plot that right there. My second one that I'm looking for, am I looking for a min or a max? I have a max at y is equal to negative 1. My axis of symmetry, x is equal to 1. Label that. For intercepts, the y-intercept in this case, we can see that y is equal to 0 because there is no c value. Let's do some factoring. When we look at this, f of x is equal to x squared minus 2x. There's a GCF in here of x minus 2. So then we have x equals 0 and x equals 2. That'll give us our 2 points here. So let's plot those. And that's all we need. We can graph it. Then we can even see our domain and range from it. Domain, x of the element of the real numbers. And range, y must be greater than or equal to -1 such that y is an element of the real numbers. Next one. This one is C. It is -x squared plus 2x plus 8. Our vertex is P is equal to -b over 2a is equal to -2 multiplied by -1, which gives us -2 over -2, which gives us 1. Plug this into Q. C minus AP squared is equal to 8 minus -1 multiplied by -1 squared is equal to 8 minus -1 squared gives us +1 multiplied by -1 still gives us -1. So -1 is equal to 9. So we have our vertex point at 1, 9. Plot that. You can already see this makes sense based off of where our y-intercept should be. Keep that in mind. Always check if your answer makes sense. 2, max or min, we have a max at y is equal to 9. Our axis of symmetry, x is equal to 1. And our y-intercept is our c value, so y is equal to 8. And then we have to do some factoring here, or use your axis of symmetry. If it is possible to easy factor, you should, so we are going to. This shouldn't be too hard. So we will start by factoring out a negative. So x squared minus 2x minus 8. I need something that will multiply to -8, but add to -2, and those two numbers we are looking for should be -4 and 2. So this will be -x minus 4, x plus 2, which means x equals -4 and x equals -2. So then we plot those. We get a nice looking parabola. And our last one here that we're looking at, we have 2x squared minus 12x plus 25. Vertex, we are looking at P is equal to -b over 2a. Is equal to -12 gives me a positive. 2 multiplied by 2 gives me 4. So we get 3. Q is equal to C minus AP squared is equal to 25 minus 2 multiplied by 12 squared. 12 squared? Nope. 3 squared is equal to 25 minus 2 multiplied by 9. 25 minus 18 gives me 7. So we have a vertex at 3, 7. Now, we can see something really apparent from where this vertex is placed in our direction of opening. Let's see if you guys can guess it. 2, we're looking for min at y is equal to 7. That should also tell you guys some things. 3, our axis of symmetry is x is equal to 3. Plot that. That's a straight line. Make sure to label it. X is equal to 3. 4, our y-intercept is 25. Now that's not super useful for what we're doing right now. We have no x-intercepts. So what we should do is we should do a test point, kind of like we did last section. So test point, mine is going to be at x is equal to 4. So 2 multiplied by 16, because that's 4 squared, minus 48 plus 25 means I have a point at 4, 9. And then using your axis of symmetry, plot. Tiny little guy up there. Our domain and range. X is an element of the real numbers, and range. Y must be greater than or equal to 7, such that y is an element of the real numbers. Cased. All right, the next thing that we need to do is we need to learn how to convert from vertex to standard form, because we can see that sometimes you get more information from the vertex form or from standard form. So the nice thing about converting from vertex to standard is that it's way easier than going from standard to vertex. We'll do that next section though. So y is equal to negative x minus 1, x minus 1. Because remember, our square symbol tells us that there's 2 of them. So then we get negative x multiplied by x gives me x squared. Negative 1x plus negative 1x gives me negative 2x plus 2 plus 9. Distribute the negative in. Negative x squared plus 2x minus 2 plus 9 is equal to negative x squared plus 2x plus 8. 7? No, this should be right here. That should be a 1. I'm sorry. Plus 1. Plus 1. And this guy changes to the 8 that I was looking for. Good. Okay, and then we're going to model a real life problem here really quickly. A farmer has 100 meters of fencing available to build an enclosure for his cows. The enclosure only requires 3-sided fencing, as the 4th side is against the barn. Determine the dimensions of the enclosure that maximizes the area of the enclosure. So we need to find these 3 lengths. We know an area of this is length times width. I'm going to call this side my length and this side my width. Now, we know that perimeter is equal to length plus 2 width in our case. Usually it's 2L plus 2W, but one of our L's doesn't matter in this case. The easiest way to isolate this would be in terms of L. Because we know the perimeter is 100, because we have 100 meters of fencing. So let's do it this way. We have 100 is equal to L plus 2W. And then we're going to go 100 minus 2W is equal to L. So now we've solved it in terms of one variable, which is useful to us. Because if we're trying to find the area, this will be length times width. But we have defined a length for ourselves. So 100 minus 2W multiplied by W. So 100W minus 2W squared. Now we have a quadratic function. We can find the vertex of it. So P is equal to negative 100 over 2 multiplied by negative 2. So 100 divided by 4 gives me 25. Now it's my x value. We'll take that and we'll plug it back in to our area formula. So this will be area is equal to, now where am I going to plug it in? I'm going to plug it into my cube, because that'll tell me the same thing. Cube is equal to, now I'm going to plug it into my area, because that will tell me the maximum of my area. So area is equal to 100 multiplied by 25 minus 225 squared. So grab your calculators. 100 multiplied by 25 gives us 2,500 minus 2 multiplied by 25 squared is some ridiculous number. 625. That's less ridiculous than I thought it was going to be. Is equal to 2,500 minus, multiply that by 2, 1,250, and 2,500 minus 1,250, and that gives me my area. So that's my maximum area. Now what you can do is you can go back and you can find out what your length is, but we have answered the question at this point. So this would be 1,250 meters squared. We should also be able to find out really easily what we're looking for in regards to what the width should be. All we would have to do is go area is equal to length width 1,250 is equal to 25 W divided by 25. Or sorry, that should be L. And then that gives us 50. All right, that should set you off for the next assignment. I do have down here that there is a link that you should follow for 27. It's very useful. 27 shouldn't be part of the homework check. If it is, cross it off. But I would heavily recommend doing this because it'll be very, very useful for your understanding of what we are doing.